Hello everyone, welcome to organolysis. So let's continue our rearrangement series. So this is another video of rearrangement reaction. Now in this particular video we are going to discuss that the Neber rearrangement, and we are also discussed an important rearrangement topic that I missed in the rearrangement reaction series, that is the 5-5 Sigmatropic rearrangement, right? Now the first topic is today's topic is the Neber rearrangement. Now what about the Neber rearrangement? Now in the year of 1926, when the scientists discovering the Beckmann rearrangement, then the two scientists, that is P.W. Neber and F. Rearrangement, reported that the successive treatment of ketoxim and trosylate with potassium ethoxide or acetic acid or hydrochloric acid yielded an alpha amino ketone, right? So this is basically the consequence of the Beckmann rearrangement. Now in case of Beckmann rearrangement, we are using this kind of substrate, that is ketoxim, but in presence of acid or any kind of SOCl2 or PCl5 like that kind of reagent, right? Now in this rearrangement, that is Neber rearrangement, we are using this ethoxide, potassium ethoxide or any acetic acid or water or any hydrochloric acid. They are going to get that the alpha amino ketone, right? So this is base induced rearrangement, and whether the Beckmann rearrangement is the acid catalyzed rearrangement, right? So this is all about the Neber rearrangement. Now let's do the mechanism and let's see the substrate and what will be the product. The substrate is similar to the Beckmann rearrangement, that is ketoxim, and this product is the alpha amino ketone. Now how will you get that one ketoxim to alpha amino ketone? So for this we have to put two reagent, that is one potassium ethoxide and another is the water. Now see for the mechanism. The mechanism is basically follows two different kind of pathway. That is the scientists believe that two different kinds of approach can be possible for this Neber rearrangement. And one pathway I also discussed both of them, but at first we are going to start that the concerted anionic pathway. So this is the first mechanism, and the second mechanism is nitrine pathway. So for that you have to know that what is the concerted anionic pathway. Now the concerted anionic pathway is basically when we are using this potassium ethoxide, so it is a base. So when we are using this, so it can take a proton. We are getting the negative charge over here. So you have this negative charge one in this position. Now this negative charge can attack to this nitrogen center, and OTS, we all know that OTS is very much easily leaving group, so it can remove in this way, so that you are getting this 3-membered ring, and it is called basically azidine intermediate. So as you can see here, that is your azidine intermediate. Now this intermediate is similar for both the mechanism when we are discussing the concerted anionic pathway, or when we are going to discuss that is the nitrine pathway. So for both of them the azidine intermediate is the same. Now when we are using this water, so this is now a strained molecule, so it will attack over here and it takes a proton, so that we are going to get this kind of intermediate. So that is just because of this 3-membered ring is strained, so it can go here and it will go over here. So it can tautomerize to get this double bond over here, and this NH2 minus takes a proton from here. Then we are going to get this product, that is our desired product, that is alpha amino ketone. So this is the one pathway. Now the second pathway is the nitrine pathway. Now what about the nitrine pathway? So this the first deprotonation by using this potassium ethoxide is the same. So this is our same kind of intermediate, that is this one, right? So when we are using this, so it can go in this resonance type of structure, so that you are getting this kind of intermediate. Now we all know that OTS is very much good leaving group, so it can easily from the system in this way, so that you are getting a nitrine intermediate. So this is our nitrine intermediate. Now this nitrine intermediate, it can go over here, so that the final product that you are getting is, this is your nitrogen, this one and this one, right? So this is your overall mechanism in this way, right? So this is right. So this is how you are going to get this product, that is your azidine intermediate. So azidine intermediate is same for both the case R1 and R2. So this is your same, and the similar pathway is followed for the same, that is when we are using water, it will cleave the ring and you are getting the final product, that is alpha aminoketone. So that is how this reaction takes place. So this is a very much important, and I found this rearrangement reaction is important for CSIR-NET and GATE specifically. That's why I am taking this rearrangement reaction in this series. So for this rearrangement you have to know some key points that you have to remember. Now the first thing is what is a required substrate. The required substrate is basically the tosyl ketoxime, or it is not necessary that you have to put the tosylate one. So you can have any chloride derivative or any kind of leaving group that can leave from the system, that you are getting either nitrine or any concerted pathway. So that is what the main substrate for the Neber rearrangement, that is tosyl ketoxime, and you have to put a base, and from what you are going to get alpha aminoketone, that is our desired product for the Neber rearrangement. So that basic difference of the between this Neber rearrangement and Beckmann rearrangement is that when you are going to do the Beckmann rearrangement, it is basically acid catalyzed, but when you have to do the Neber rearrangement, you have to put a base, and that substrate must be contain an alpha hydrogen. So the third point is, this is your 1/1 point that you have to remember. Number 3 point is that the compound having at least one alpha hydrogen. So this point is remember for this reaction, that is you have to check whether the molecule has any alpha hydrogen or not, right? So this is the one more important concept for this Neber rearrangement. Now this reaction is not stereospecific. Now why it is not stereospecific? Just because it is not influence the outcome of the reaction, that is when we are going to get this is product or syn product or trans product, so it will not define that much. So that is why this reaction is not stereospecific in nature. So this is all about the Neber rearrangement. Now let's see some examples which is a consequence of this reaction. Now see the example first. Now we have the first example, that is a pyridine kind of derivative with this COMe attached with this pyridine, and one more thing is that how to get this kind of derivative, that is your tosyl ketoxime. So that is what you have to put this NH2OH in presence of HCl, and the second step you have to put this tosyl chloride in presence of protein. So what it can do, it can attack over here, it can go like this. After the removal of the water, you are going to get this product, that is basically this one. So there is no space, right? So this is your OH, this is your methanol. So this is what you are going to get, but from here to here you have to put this tosyl chloride. So this OH minus, this pyridine can take a proton from here, this O minus will attack over the TS, and Cl will leave from the system, so that you are going to get this final that is tosyl ketoxime derivative, that is your main substrate for the Neber rearrangement. Now when we are using this potassium ethoxide or HCl, so we have the one point you should remember, that is your alpha hydrogen. So we have the alpha hydrogen over here, so it will take a proton from here, that is I am writing this CH3 in this way. So it can take a proton from here, it will attack over here, this OTL will leave from the system. The final product from here that you are going to get is this one, double bond, that is NH2, right? So when we are using this ethanol in the medium, so it can protect this double bond in the form of acetal. So this is your acetal form, and it can protect when you are using this HCl in presence of ethanol. So if this ethanol attack over here, this OH, and further attack of 1 mole of ethanol, you are going to get this kind of acetal product. So this is your final product. Now the next thing is that the next important example of this reaction is this one. When you are using the HOCl, so what will be the product? So this NH will remove from the system, and you will going to get this NCl. Now you can see that there is no necessity of this tosyl ketoxime has to be done there. So there can be the N-chloro or any kind of leaving group attached with this nitrogen, so that Cl will attach to the nitrogen, so Cl can easily leave from the system. So that is what you are going to get this one. intermediate, and after using this one you have the alpha hydrogen over here, so that you will finally get this product, that is alpha amino ketone. So one more short trick I can tell you what is that when you have the alpha hydrogen, so you can you can easily predict when you have the alpha hydrogen, you know that the product is alpha amino ketone. So from the name you can easily predict that when you have the alpha hydrogen, so NH2 group has to be placed in the alpha hydrogen position. So what is meant by that? If you have this kind of substrate, that is R prime, so this is the alpha position, that is your alpha hydrogen, so the product should be in this way, that you have to remove this N by using a double bond, and you have to put this NH2 group in this alpha position. So this is how you can easily predict, or is in the examination you don't need to write the overall mechanism, so you can easily predict by using the short trick, right? So this is your short trick for this reaction. Now the last example for this reaction is that you are putting this tosyl chloride and K2CO3, so it will take a proton, and after that you are going to get this OTS derivative. So after the final product, so I can tell you that I will already tell you that what is the short trick. So you can easily predict that you have to remove this double bond N by using a double bond O, and in the alpha position you have to put this NH2 group. So that is what we are doing here, that is NH2 group over here. But when you are using this ethanol in excess, so this double bond O will further protected by using this acetal. So this is your acetal formation by using this OED, right? So this is all about the Neber rearrangement. Now let's move on to the next topic, that is the benzene rearrangement, or it is called the 5,5 sigmatropic rearrangement. So this is what is very much important for the reaction, right? Now what kind of substrate undergo this 5,5 sigmatropic or benzene rearrangement? Now why the name of the reaction is 5,5 sigmatropic or benzene? Now the substrate which will undergo in this benzene rearrangement or 5,5 sigmatropic is that is your hydrazobenzene. So this is your hydrazobenzene, and when you are using this HCl in the medium, you are finally going to get this benzene derivative. Now along with this benzene derivative, you also get the ortho substituted one or meta substituted product, or any kind of parasamidine like product. So they are basically called the parasamidine. So this is the major product that you can see here, that is 70% of the product you will get from the hydrazobenzene into benzene. So that is why I am taking this here, that is a benzene one. I am not writing the overall as parasamidine or orthosamidine. So what is this structure of samidine? See here, that is basically this one. This is NH2 and this is another NH2. So this is basically called the parasamidine. Similarly, when you have the orthosamidine, so orthosamidine is basically the connection between this ortho group here to here. I can write in this way, that is your NH2. So this is your NH2, right? So this is your called orthosamidine. So this is your orthosamidine. Now the next thing is like the mechanism. So what will be the mechanism? So you can see here this two nitrogen has a lone pair, so it can take a proton from here and here. So that is why I am written over these two hydrogen, so it can take here the proton, this NH2 NH2 plus. Now we can write this structure in this way also. So this is the similar structure of it. Now the main important thing of the reaction is that the 5,5 sigmatropic. Now I already told you how to numbering of this compound. So first of all you have to write this 1 2 3 4 and this is your 5. Similarly this is your 1 2 3 4 and this is your 5. So the 5,5 sigmatropic means there is a formation of bond between this 5 and 5. I can write this 5 prime as well. So this is your 5 prime. So there is a bond formation between 5 and 5 prime, and there is a bond breaking between 1 and 1 prime, right? So this will go here, this will go here, and it can go over here. It will go here, it will go here. So this is all about the overall 5,5 sigmatropic mechanism. This is the probable mechanism for it. Now there is a bond formation between 5,5. So you are going to get this bond, that is this one, and you have this bond breaking between this one 1 prime. So that is what you are going to get. Now it is now dearomatized, so it can get its aromaticity back. So that is what will be the product, similar in this way. So that is what you are going to get. That is your, from hydrazobenzene you are finally get this benzidine. So this is your benzidine as a major product, and it is also called the benzidine samidine rearrangement. So this is, you can see here, this is your samidine, and from this you are going to similarly you are going to get this parasamidine or orthosamidine, like that. So this is all about the samidine rearrangement. Now the next important example of this reaction is that when you are using this this substrate by using HCl, you are going to get this product. So you have the substituted over here, that is COOH, and how to remove that. So if you see carefully the mechanism, then you can easily predict. So by using HCl, this will take a proton, and similarly this will take a proton in this way. So the final product, the intermediate look like this COOH, right? Sorry, this is your hydrogen, this is your COOH, right? So now the mechanism should be like this. This is your positive, this is your positive, these bonds go here, this will go here, it can go here, like this. So this is your major step for this rearrangement reaction. Now you have to write this structure in this way. It is a double bond NH2 plus, go here, this is what it is, right? Now you have the COOH group is this way. So we can write this structure in this way. Now it will going to get back its aromaticity, so it can decarboxylate in the following way, and here is your hydrogen. So this will be the observed mechanism for this product. So it can decarboxylate, there is a removal of this CO2 group, and finally you are getting this final product, that is this one. So this is also your benzidine. From this if you have a SO3H in this position, so the similar mechanism has been takes place. Okay, so now this is all about the 5,5 sigmatropic. Now let's come to the question, which was came in CSIR-NET December 2011. The question says that you have given the substrate and you have to predict that what kind of the given answer is such like that if you have to predict the mechanism type, that is either it is C33, C5 or 5,5, and you have to predict the product also. Now if you see carefully and if you do the numbering of this reactions carefully, then you can easily predict what will be the product. This is your 1, so this is your 2, 3, 4, and this is also your 5, and similarly you can write here 2, 3, 4 and 5 prime, you can write in this way. So you can easily see from here, that is this can be, and heat also given to you, so the product should be followed the 5,5 sigmatropic. And how it can be takes place, see here, there is a bond breaking between 1 and 1 and bond formation between 5 and 5. So from here you can easily predict the final product in this way. So see, this is how simple the question was, that you have to do this one. So this is your final product. So this is your final product, and this is basically your it is final year tautomerizes and to get the final product, and this is follows the 5,5 sigmatropic. The only one question which was came in CSIR-NET exam, I already covered this topic, and that's it for all this rearrangement reaction and of the benzidine samidine or 5,5 sigmatropic rearrangement reaction, and as well as the Neber rearrangement. And if you have any doubt regarding these two 5,5 sigmatropic or Neber rearrangement, you can feel free to ask me in comment section. I can definitely try to answer all those questions, right? So if you haven't subscribed this channel yet, so go and subscribe this channel and press the bell icon, so that you are going to get the earlier notification from my channel. And if you like this video, share it with your friend as much as you possible. And that's it for this video, and thank you so much for watching.